Okay, sound event detection. While everything else is loading for the next video, I wanted to go ahead and just give a quick overview of what this looks like, so it all makes sense as we're going forward. We'll try to do it quick while using Google Drawings. You know, it's always a challenge. So, sound event detection. We have this audio file here, right? This audio file we're going to divide up into 20-second segments. All right, these aren't going to be even, but whatever. We're going to pretend that each one of these little lines is 20 seconds of that audio file. And yeah, okay. But really, a bird call is not 20 seconds long. It's like 2 seconds. At least enough information that we can identify that bird is in about 2 seconds. However, this long audio file here, that is, let's see, 1, 2, 3, there's a minute, 1, 2, 3, that's 2 minutes of audio. And these are like 15-minute audio files, some of them are a lot shorter. But regardless, the majority of the sound in these files is not of the bird that the audio file is marked for, right? Like this might be marked as, let's pretend it is bird number 48. All right, it's class ID 48. But the majority of all the audio in here is not for bird 48. It's for background audio, maybe another bird that just happened to be in there, whatever. So sound event detection, is what we do is we send in all the audio files and we put a big window on them. For example, in this, we're going to use a 20-second window. And we're going to assume that every bit of audio in all of the files for class 48 are for bird 48. And so we make a model from that. Boom. This drawing is just going horribly, but hey, it doesn't matter. So we have some model. I'll just label it as model 1. Okay, so we're going to train model 1 with all this data. And then from model 1, we're going to feed back in. See if I can do a loop one here. Curved connector, maybe that'll work. Whoop. Boom. We're going to feed all that data back into model 1 to classify it. And so model 1 is going to get this audio file, or all the audio files for bird 48 and all of the birds, and it's going to get them in 20-second chunks. And we're going to look at which 20-second chunk it says is bird 48, right? Like it's probably not going to classify all these as bird 48, or at least none of them with a very high score. So we're going to throw away everything that doesn't get a high score and keep everything that does get a high score. And then we'll do this whole process again. Oh. We'll do this whole process again here. And make another model. Yeah, whatever. You'll get the point of this. Probably don't even need to keep drawing now because you understand what I'm talking about. Except in model 2, our chunks are going to be smaller. Let's say we're going to use 10-second windows. So we're going to take only the portions of bird 48 audio from the first iteration that had a high score. Then we're going to divide those up into 2, and we'll use 10-second chunks of that, and to create another model from this. Assuming that that audio data is better because we already ran it through one model. And then we're going to do this whole process again on a third model. And this time we use 2-second windows to actually figure out which portions of the audio are really valid. And then, just in case you're not aware, I wasn't at first. I had no idea how you actually send audio data into a model, right? You have WaveNet, and WaveNet. Let's see if we can find a cool little picture of it. This is the most common one. Right over there. That's the WaveNet picture. Here. And WaveNet is a big, big model, and it actually sends in the individual values of every frame in the wave, right? So if you're looking at 16K audio, that's 16,000 values going into this. And I haven't addressed this yet, but one of the things that we're trying to do with this model is deploy it very easily and small. Yeah, compactly. We want it to fit on a mobile device. I don't want to have to run a server that actually classifies all this bird audio and sends it back. That might be useful later on. We could use a much bigger model there. But right now, we're just trying to get this out onto a device or go to a website. You know, you go to birder.ai. You can go to app.birder.ai, and it loads up this model right away. Boom. So our model is already loaded. I think whenever we click listen for birds, and it should be listening for birds. This would be a good thing to show already. This is what birder.ai kind of looks like. And it's probably in a fight to grab my microphone, or it's listening for a bird and it can't classify one, because thankfully I don't sound like a bird right now. But we need the model to be small, right? That's what we're getting back to right now. And that's why we're not using WaveNet. WaveNet could be better, and it's actually not for classifying anyway. WaveNet is for creating new audio. It can be used to classify it. I used that for a while before I fully understood how to use WaveNet. We're not using WaveNet. We are creating spectrograms from this bird audio, right? Little pictures. Then from that spectrogram, we are sending it in to just pretty much a basic CNN. And this is what spectrograms look like. Again, in case you are not aware of it, towards data science is great. And you create spectrograms using the fast Fourier transform. It's a math that pretty much looks at how the wave is changing from one frame to another frame. Not just frames, you're kind of using a bigger chunk there, which you end up calling it the N. I think on here we use an N of like 256 or 128. We'll look at that in the next video. Anyway, that's what we're going to be doing. We're going to take all this bird audio, we're going to create spectrograms from it, from 20-second segments, create a model, go send all that data back in, classify it, figure out which ones come back, do that again, and then we'll take the output of that and actually consider that valid training data to create model number 3, which is what we'll package into the app. Okay,